when you look at the sheer volume of enterprise tech news
Yeah.
hitting our desks right now, especially tracking it week by week, it is just, it's so easy to get completely overwhelmed.
Oh, absolutely.
Yeah, between the acronyms and, the version numbers, it kind of feels like the entire industry is just pivoting underneath our feet.
It really does.
So, welcome to another deep dive. Today, we are taking a massive stack of technical updates. These are straight from the July 2026 weekly newsletter. And our mission is to, well, basically filter out the noise for you.
Right, getting to the good stuff.
Exactly. There's this incredible list we're looking at across Azure, Microsoft 365, Power Platform, DevOps, data, AI, security. I mean, it's a lot. But we want to dig into the actual mechanics of what these updates mean for the people building and securing these systems.
Yeah, and I think that is the right approach because when you look at these sources holistically, there is a very, very clear narrative emerging. We are completely out of the sort of what-if phase of artificial intelligence.
A hype phase, basically.
Exactly. The hype phase is over. The toys are back in the box.
Yeah.
We are now in the hardcore infrastructure and agentic operations phase.
Right.
Now, the industry is figuring out how to weave AI agents directly into the fabric of enterprise IT, which, as you can imagine, is forcing us to tear down and rebuild how we handle deployment pipelines, network security, data architecture, all of it.
So let's jump right into the bedrock of that architecture, which is Azure infrastructure. Because there's a headline here that honestly made me stop and reread it.
Oh, the Linux one.
Yes, Azure Linux 4.0 is now available as an ISO for bare metal servers and virtual machines. I mean, hold on. Is Microsoft seriously positioning a native Linux distribution to, take over the enterprise server room from Windows Server?
Well, okay, it is not a hostile takeover.
Right.
But it is a massive acknowledgement of reality. Azure Linux 4.0 is absolutely stepping into the ring as a heavyweight competitor to your mainstream enterprise Linux distributions like Red Hat or Ubuntu.
Wow.
I mean, think about the mechanics of modern cloud-native architecture. You've got containerized workloads, Kubernetes clusters, and especially, and this is key, the incredibly dense AI workloads we are seeing right now.
Which are just everywhere.
Exactly. And those are all fundamentally built on and optimized for Linux kernels.
So Microsoft is basically just looking at the telemetry, seeing that developers are spinning up millions of Linux VMs anyway, and they're just deciding they want to own that entire stack natively.
Yeah, that's exactly it.
Okay.
By offering Azure Linux 4.0 as an ISO for bare metal, they're giving you a hyper-optimized, stripped-down OS where they control the security patching and, the kernel updates from the silicon all the way up to the cloud.
Okay, that makes sense. It reduces the overhead.
Right. And speaking of foundational architecture, there's a major shift flagged here with Azure Landing Zones, or ALZ.
Yeah, ALZ. I always thought of ALZ as just like a really robust GitHub repository.
Yeah, a lot of people did.
Like just a collection of ARM templates and bicep code that the community put together to help you set up your cloud. Right.
And it was. For about 5 years, it was this grassroots, open source scaffolding blueprint. You used it for things like virtual network tiering, role-based access control, Azure policy.
Right.
But the update here is that ALZ has officially entered its next chapter. It is now an official Microsoft product, owned and maintained by the Azure Migrate product team.
It's kind of like a highly successful community garden finally getting official city funding and becoming a state park.
Oh, that is a great analogy.
But what does that actually change for a cloud architect? Like practically? Does it just mean there's a new shiny logo on it?
No. It changes the entire risk profile for an enterprise.
How so?
Well, when it was a community project, if an Azure API changed and it broke your deployment script, you had to wait for an open source contributor to fix it.
Oh, right.
All right.
You're just hoping someone on a weekend pushes a patch.
Exactly. But now that it's an official product under the Azure Migrate team, it has enterprise-grade backing. You get service-level agreements, dedicated engineering support.
So if you're a big enterprise, you actually have someone to yell at if it breaks.
Exactly. If you are building a massive, scalable cloud environment for a Fortune 500 company, you need that official product support. You need the throat to choke, so to speak.
Right. You need the official stamp before you trust it with your core business.
Yeah.
I get that.
Mm-hmm.
There was also a quick update mentioned on Cosmos DB design patterns.
Yeah?
Why is that relevant to this whole AI shift we're talking about?
Because an AI agent is really only as fast and as accurate as the data layer it queries.
Okay. Yeah.
If you don't get your database architecture right, like if you choose the wrong partition keys or you fail to set up georeplication properly, Your hyper-intelligent AI agent is going to spend 90% of its time just sitting there waiting for a database read operation to complete.
Which totally defeats the purpose of having a fast AI.
Exactly. So Cosmos DB design patterns, they just provide these proven structural blueprints to ensure your database can handle that immense read and write throughput that these autonomous agents require.
All right, so if Azure and Cosmos DB are like the foundation, let's look at who is actually pouring the concrete. I want to move into the builder's toolkit side of things, DevOps, SRE, and the developer frameworks.
Let's do it.
We have some rapid-fire updates here. TypeScript 7.0 was announced, which is huge, and Logic Apps standard now supports local functions and flat file schema generation. Let's start with Logic Apps. What is the actual mechanic behind that flat file update? Because it sounds incredibly niche.
It does sound niche, yeah, but it is a massive operational bottleneck solver.
Okay, how so?
Well, large enterprises still rely heavily on legacy mainframes.
Right.
And those mainframes spit out data in these fixed-width flat files.
Just massive blocks of raw text.
Exactly. No JSON, no XML structure, just text.
Yeah.
Historically, an integration developer had to sit there and spend hours writing these insanely complex regular expressions just to parse that data.
Oh, wow. Yeah, RoJX is nobody's idea of a good time.
Right. But this update means Logic Apps can now automatically analyze that block of text, infer the schema, and map it for you.
That's amazing.
Yeah, it basically automates the most tedious part of enterprise integration.
Okay, I definitely see the value there. But let's get to the warning sign from the sources, because this one sounds critical. NTLM is being removed in Git, specifically in libcurl.
Yes, pay attention to this one.
I know NTLM is an old authentication protocol, but why is its removal a 5-alarm fire for anyone using Azure DevOps Server?
Well, NTLM is this old challenge response authentication protocol. It literally dates back to the 1990s.
Wow.
And from a security standpoint, it is highly susceptible to pass-the-hash attacks. That's where a bad actor can steal a hashed password and use it to authenticate without ever actually knowing the real password.
That sounds bad.
It's terrible. The industry has been trying to kill NTLM for a decade, but a lot of on-premises Azure DevOps server environments still fall back on it.
Right.
So by removing NTLM support in libcurl, which is the underlying URL transfer library that Git uses, the Git client is simply going to refuse to authenticate using that protocol.
Okay, so what happens mechanically to a developer on like a random Tuesday morning in September if their org hasn't migrated?
Mechanically, they type git fetch or git push in their terminal, and the pipeline literally just times out. Or it returns an access denied error, the connection just drops.
Oh, so they're just totally locked out.
Completely.
Yeah.
You have to ensure that Kerberos authentication, which uses a much more secure, time-stamped ticket granting system, is fully configured and operational by September 2026. If you don't, your developers can't access their own code repositories.
That is a hard infrastructure breaking deadline.
They're very hard.
Okay, definitely good to know.
Mm-hmm.
Let's pivot slightly to the AI developer side of things, because the agent framework's orchestration patterns have officially reached version 1.0.
This is huge.
Now, I get that building a single chatbot is pretty easy now. You just hook up an API. But why is multi-agent orchestration so mechanically difficult that we needed a dedicated 1.0 framework for it?
It really comes down to state management and infinite looping.
Infinite looping.
Yeah. Imagine you have one agent that analyzes an incoming email, another agent that checks inventory, and a third that drafts a reply.
Okay.
How do they hand off data? What happens if the inventory agent fails?
Does it just crash?
Right. Does it retry? Does it pass an error back to the first agent? Without a standardized framework, developers were essentially writing thousands of lines of fragile custom code just to manage the conversation between these AI models.
Which sounds like a maintenance nightmare.
Exactly. So Orchestration Patterns 1.0, it provides the standardized logic gates and memory management for those handoffs.
And this ties directly into the Azure API Management update, right? APM now lets you turn any standard REST API into an MCP server.
Yes, the Model Context Protocol.
Right, MCP. I need you to break this down for me. What is the Model Context Protocol actually doing here?
Okay, so think about how an AI model interacts with the outside world. Ultimately, an AI is just a math engine predicting the next word. If you want it to actually take an action like creating a ticket in Jira, it needs to know the exact URL, the exact headers, and the exact JSON payload format that the Jira API requires.
Right, which usually means a human developer has to hard code those specific instructions into the AI's prompt, don't they?
Exactly. You're constantly updating prompts. The Model Context Protocol changes that. It's an open standard that allows an AI model to dynamically discover and understand an API's capabilities on its own.
Wait, on its own?
Yes. By turning your internal REST APIs into MCP servers through Azure APM, you are essentially publishing a machine-readable menu.
Oh, that's brilliant.
The AI can look at the MCP server, instantly understand the exact formatting required to make a request, and execute the API call perfectly without a developer having to hard-code the integration.
So basically, we are giving these AI brains a standardized set of hands to actually go out and interact with our existing software.
That is exactly what it is, a standardized set of hands.
Okay, that is wild. So we have the hands connected and standardized. What is actually powering the brains? Let's dive into the data, analytics, and AI models section of the news.
Lots happening here.
Yeah, the June 2026 Microsoft Foundry updates show that Anthropic's Claude models are now generally available, and they're running on NVIDIA Blackwell Ultra systems.
Yeah.
But why is Microsoft hosting a competitor's model on their absolute top-tier hardware?
Because enterprise customers demand choice, but they absolutely refuse to compromise on data sovereignty.
Security.
Right. While OpenAI models are fantastic, certain Anthropic Claude models might perform better at specific tasks, like, say, analyzing massive legal documents. But a bank or a healthcare provider is not going to send their highly sensitive data out over the public internet to an Anthropic API endpoint.
No way. The compliance teams would have a heart attack.
Exactly. By hosting Claude natively inside Microsoft Foundry on Blackwell Ultra chips, Microsoft allows that bank to run the Claude model completely within their own secure Azure virtual network. The data never leaves their tenant boundary.
That makes total sense. And the model landscape itself is just exploding right now. You look at the sources, and OpenAI has launched the Frontier Enterprise platform. There's massive buzz comparing GPT 5.3 codecs with Claude Opus 4.6, and even rumors floating around about GPT 5.6 and OpenAI's Solana, Terra, and Luna models.
It's moving so fast.
But with massive new foundational models dropping every few months, how does an enterprise afford the compute to keep retraining their internal tools?
They can't. They really can't.
Really?
Yeah, doing a full fine-tuning run on a massive foundational model, updating billions of parameters using gradient descent, it takes thousands of GPU hours and costs a fortune.
Which brings us to the research paper you highlighted from Microsoft Research called SkillOpt.
Yes, SkillOpt. This is arguably the most important piece of news in this entire stack.
Okay, I read through the SkillOpt summary, and I'll be honest, I'm a bit lost on the mechanics. How do you teach an AI agent a new skill without actually retraining the underlying model?
Right, so SkillOpt uses a technique similar to LoRa low-rank adaptation, but it's specifically optimized for tool usage.
Okay.
Think of the massive foundational model as an employee who has a really broad general understanding of the world. Now, you need them to learn how to use a highly specific internal accounting software.
Right.
You wouldn't send them back to college for 4 years just to relearn everything they already know, right?
No, of course not. It's like teaching an employee a new procedure without making them get a new 4-year degree. You just give them a tiny, highly targeted training manual just for that one software tool.
I love that analogy, yes. SkillOpt treats an agent's specific skills, like how it structures a SQL query or how it uses a calculator, as a tiny isolated matrix of trainable parameters.
Oh, wow.
It freezes the multi-billion parameter-based model so those weights don't change at all. It only updates this tiny external matrix.
So it's incredibly efficient.
Massively. This means you can drastically improve how an agent uses your internal tools using a fraction of the compute power, and you can even swap these skills in and out dynamically.
That is a game changer for cost. So we have highly optimized, cost-effective AI brains. But, if I'm a sales rep or a customer service agent, a foundational model doesn't really help me close a ticket, right?
Right. It's just raw potential.
Exactly. So how do these tools actually surface in the applications people use every day? Let's look at the business value across Microsoft 365, Power Platform, and Dynamics.
Well, from an administrative side, tracking this AI integration is getting a lot easier. The Microsoft Copilot Studio and Agent roadmaps have officially moved to the centralized Microsoft 365 roadmap.
Nice.
Yeah, it gives IT admins a single pane of glass. And for everyday users, Windows Settings Backup is quietly becoming a new baseline for endpoint resilience.
So if my laptop motherboard fries, I can just log into a new machine and my exact desktop environment, applications, everything just restores seamlessly from the cloud.
Exactly.
That is so nice. But the major shift noted here is in Dynamics 365, specifically around agentic CX or customer experience.
Yeah, this is a big leap forward for sales and service orgs.
How is an agentic customer experience mechanically different from the basic chatbots we've had for the last 5 years?
Well, a traditional chatbot follows a rigid decision tree, right? If the user says X, output Y, it is entirely scripted.
Press 1 for sales, press 2 for support.
Exactly. But agentic CX in Dynamics 365 means the AI is given a goal and the actual authority to figure out the steps to achieve it.
Authority. Like what?
Okay, so if a customer emails saying they received a damaged product, the agent can autonomously read the email, query the inventory database via those MCP APIs we discussed earlier.
It all connects.
Right. It can then initiate a replacement order, draft an apology, and process a partial refund all in one autonomous multi-step workflow.
That's incredible. And to make sure those agents aren't just, hallucinating answers or giving away free money, Foundry IQ is now integrated directly into Copilot Studio.
Correct. That provides retrieval augmented generation, or RAG, natively. It grounds the agent's conversations and reasoning in your actual enterprise data hosted in Foundry, rather than just relying on whatever the model learned from the public internet.
Okay, so a quick nod as well to Power BI's shape map, reaching general availability for better geospatial visualizations. But I want to get to the security preview you brought up.
The Power Pages update.
Yes, native Dataverse authorization is in public preview for Power Pages. I know Power Pages lets you build external-facing websites, but what exactly is Dataverse, and why does native authorization matter?
So Dataverse is the highly secure relational data backend that powers all of the Power Platform in Dynamics 365.
Okay.
When you build a public-facing website using Power Pages to let your vendors or your customers interact with you, you are inherently exposing a pathway to that Dataverse.
Which sounds risky.
It can be. Previously, securing that connection required complex custom API gateways. Native authorization means you can enforce strict row-level security policies directly on the Dataverse layer.
I see. So a vendor logging into your Power Page only sees the exact rows of data they are explicitly authorized to see, and it's enforced at the database level.
Exactly. It acts as the perfect bridge to the next topic, actually.
Yes, the shield. Security, compliance, and privacy in the AI era. Because, if Power Page is exposing Dataverse, and we have these AI agents autonomously executing multi-step workflows with full authority, how are we not just leaking proprietary data everywhere?
That right there is the existential question for enterprise IT right now.
Yeah, there's a headline here from HelpNet Security. Organizations struggle to prioritize known cyber risks. With all this new AI agent activity, how do we even secure it?
Well, the Microsoft Entra guidance gives us a major insight here. We now have to govern AI agent identities and their access the exact same way we govern human employees.
Wait, really? Like giving an AI an employee badge?
Basically, yeah. Non-human identities are the new security perimeter. If an AI agent has the ability to query your financial database, that agent needs its own dedicated service principal in Microsoft Entra. It needs role-based access control. It needs its access reviewed every 90 days. And most importantly, it needs conditional access policies.
So if that agent suddenly tries to bulk download financial records at, say, 3:00 a.m. from an IP address it has never used before,
Entra needs to instantly revoke its token, just like it would for a human employee whose account was compromised.
Wow. That sounds like a massive amount of administrative overhead, but I completely see why it's necessary. I was also really excited about a new joint feature from Microsoft Purview and Microsoft Entra. They're extending data detection and identity-aware enforcement to the network layer.
This is a huge step forward for protecting data in motion.
Right, because traditional data loss prevention, or DLP, it feels a bit like trying to catch a runaway horse after the barn door is already open,
Yeah, endpoint DLP is tough.
But this new network-level security, it's like having a smart checkpoint that recognizes the horse and closes the gate before it even tries to leave. How is it mechanically different from the endpoint scanners I already have running on my laptop?
Well, traditional endpoint DLP usually works by scanning your hard drive for specific file extensions, or it tries to hook into the Windows operating system to monitor when a user hits Ctrl-C and Ctrl-VV.
Right, which always seems to slow down my machine.
Exactly. It is notoriously fragile and resource-heavy. Network layer DLP doesn't rely on the operating system at all. It inspects the actual TLS decrypted network packet stream at the proxy or gateway level.
So it's literally looking at the data as it's actively traveling over the wire.
Yes. So let's say an engineer highlights a block of highly proprietary source code, copies it, and pastes it into an unsanctioned, consumer-grade AI chatbot in their browser.
Which happens all the time.
Constantly. Endpoint DLP might miss that entirely because no file was attached and no local document was saved.
But the network layer DLP sees the HTTP POST request going out to the chatbot servers.
Exactly. It inspects the payload of that outgoing web request, uses data fingerprinting to instantly recognize the proprietary code, checks Entra to see the user's identity context, realizes they are trying to send it to a shadow AI application.
And it just blocks it.
It drops the network packet before the TCP connection can even complete the send. It preemptively stops the data leak in real time, completely independent of the endpoint hardware.
That is an incredibly powerful mechanism for stopping shadow AI.
And it's a core component of Microsoft's Secure Future Initiative, or SFI. They are proactively hardening the infrastructure at the network layer at AI speed to keep pace with these automated, agent-driven data movements.
Wow. All right, as we start to wind this deep dive down, I want to zoom out to the horizon section. We're talking about broader industry trends and what it means for your career. And it seems like not all of this compute is staying in the cloud. The hardware wars for local AI are really heating up.
Oh, absolutely. Building AI locally is becoming highly competitive.
You flagged the video reviews comparing AMD's new Ryzen AI Halo architecture, specifically the Strix versus Spark chips for developer workstations. Why do developers need that much dedicated neural processing power on their laptops if the heavy lifting is done by Foundry in the cloud?
Two things, latency and cost. If a developer is testing a smaller, specialized agent framework locally, they don't want to wait for round-trip network latency to the cloud for every single prompt.
Right. That would be incredibly annoying.
And they certainly don't want to incur cloud compute costs just to debug a script. These MPU's neural processing units, baked into the local silicon, allow them to run highly capable, quantized models directly on their workstation with zero latency and zero cloud bill. It brings the power right back to the edge.
That makes a lot of sense. You also highlighted two fascinating Horizon projects that feel like they are cutting-edge research. First, Cloudflare's Meerkat. What is the physics problem this project is trying to solve?
It's the problem of global consensus in distributed systems.
Okay, break that down for me.
If you have an application deployed globally, getting a server in Tokyo and a server in New York to agree on the exact state of a database at the exact same millisecond, it is literally bound by the speed of light.
And you get data collisions.
Exactly. Meerkat is an experiment in global consensus. It's exploring novel, edge-optimized, distributed state machines, kind of similar to Raft or Paxos protocols, to solve that latency bottleneck and ensure global data consistency without slowing down the application.
And then there's the National Science Foundation launching Project Triad. This is an initiative focused on accelerating real-world quantum technology applications.
Yeah, it really highlights that while we are hyper-focused on AI agents today, the quantum wave is already building in the background.
It never stops. But, keeping up with all this bleeding-edge tech doesn't mean we abandon the foundations. I noticed you made sure to include the newly announced exam for the Microsoft Certified Windows Server Administrator Associate.
I included that intentionally, yeah, because even as we sit here talking about AI agents and network layer DLP and quantum computing, the vast majority of enterprise infrastructure still relies on fundamental server management, Active Directory, and networking principles.
You still need to know how the pipes work.
Exactly. The technology evolves, but understanding the core plumbing of how systems talk to each other is a career skill that we'll never depreciate.
Well said. We have covered an immense amount of ground today. Thank you all for coming along on this intense journey through the newsletter.
Yeah.
We've gone from the mechanical realities of Azure Linux 4.0 and the Git NTLM deprecation to the orchestration of model context protocols, all the way to SkillOps parameter training and network-level packet inspection.
But before we sign off, there is one final brand new concept from the sources that I want to leave you with. As we build and deploy these agentic AI systems, where agents are autonomously querying databases, invoking APIs, executing multi-step workflows,
Right.
we aren't just managing traditional server uptime or storage capacity anymore.
Right.
We are managing token consumption.
Wait, token economics.
Exactly. FinOps for AI is going to be the next massive career opportunity. Every single action an agent takes, every API payload it analyzes costs fractions of a cent in compute tokens.
And when you scale that up to thousands of autonomous agents running millions of microtasks across an enterprise,
those costs can spiral out of control in a matter of hours. So the next massive challenge for IT leadership isn't just building the agents, it is governing their economy. who in your organization is tracking the economy of your AI workforce to ensure it doesn't bankrupt your cloud budget?
That is a phenomenal, provocative question to end on. It really forces you to look past the capability of the tech and focus on the operational reality. So take some time to explore those token economics, review your non-human identity governance in Entra, and stay curious until our next deep dive.